Okay, so this video starts off talking about measures of central tendency. So the mean, which is another word for average, and you calculate it in the same way you would calculate the average. It's just you're going to add up all the data values and divide by the number of data values that you have. So a simple example, if my data set was 1, 2, 3, 4, 5, add all of those together and divide by the number of 5 because I have 5 data values. So 15 divided by 5 is 3. So the mean or the average would be 3. Okay, the median. You think about middle. When you think about median, it's going to be the middle value. List the data values from least to greatest. That's the step that a lot of people forget. So make sure you hold true to that. List all your data values from least to greatest first. Then, if the number of data values is odd, then you're going to choose the middle value. If the number of data values is even, then you take the mean, or in other words, the average of the two middle values. So if I have 1, 2, 3, 4, 5, I have 5 data values. That means I actually have a middle value. So my median would be 3. If my data set was 1 through 6, I do not actually have a middle value because I have 6 numbers. I have an even set of numbers. So I take the two middle values, which would be 3 and 4, add them together, divide by 2, and that will be the median. That would be 3.5, and you notice 3.5 is in the middle of the 3 and the 4. Right. The mode, you think about most. The mode is the data value that appears the most frequently. It is possible to not have a mode. If the data set has 2 modes, it's considered bimodal. If the data set has more than 2 modes, then it is considered multimodal. So if I had the data set 137245879969173 8572437, the mode would be 7 because 7 appears the most amount of times. Then we're looking at the mid-range. The mid-range is the value that is halfway between the minimum and the maximum data values. So your mid-range would be taking the minimum, adding it to the maximum, and then dividing by 2. So if I have the data set of 1 through 7, I take 1, which is my minimum, take 7, which is my maximum, add them together, that give me 8 divided by 2. My mid-range would be 4. Measures of dispersion. So your range is going to be the difference between the maximum data value and the minimum data value. So you just do max minus min. So if my data set was 1 through 8, my maximum is 8, my minimum is 1, so 8 minus 1 is 7. So that would be my range. My data set range would be 7. Next, we're looking at our standard deviation. It's a measure of how much a data value deviates from the mean, or in other words, the average, or it represents how far a data value is from the average. The variance is another way to measure the spread of data, and it's just your standard deviation squared. So our book doesn't focus on the process of calculating the standard deviation and variance, but the application. So not the application, not the calculation, but the application of the standard deviation and variance. So what you need to do is make sure you find an app, website, or calculator that can calculate the standard deviation or the variance. An example of that is easycalculation.com, where there are plenty of apps, free apps and free websites that you can use that are reliable, that can calculate the standard deviation and the variance. So make sure you find something of that nature. So a quick example that you can test it by, it says find the standard deviation and variance of the sample. Notice it says sample, 2, 4, 7, 12, 15. So your standard deviation of this sample is 5.43, and the variance should be 29.48. So notice I mentioned sample. Always make sure you pay attention to whether you're dealing with the sample versus the population. The population is the whole body. A sample would be a piece of that body. So in other words, if you look at a college, the college student body is the population of that college. One classroom would be a sample of that student body population. So there is specific notation for the population versus notation for your sample. And if you see that notation, they don't have to mention that you're dealing with a sample. You would already know by the notation. So here we have Greek letter mu. That's the population mean, population average. Here we have Greek letter sigma. That's lowercase sigma, not capital sigma. That's the population standard deviation. Sigma squared is the population variance. And capital N is the population size. X bar, X with just a bar over it, is your sample mean. The regular letter S is your sample standard deviation. S squared is your sample variance. And lowercase n is your sample size. And then just a regular letter X is your data value. Whether you're dealing with a population or a sample, X will always be a data value. Let me know if you have any questions.